Hi guys, let's review the optical isomerism part 1 quiz. This quiz comprises the first two lectures of optical isomerism. Okay, so we started with basics of optical isomerism and we learnt about R and S isomers. We did diastereomers, meso compound. I have not included questions on allenes, pyrenes because as I told you that is not that high weightage. So adana thaniya chinna quiz anatara. This quiz does not have the questions from lesson 3 of optical isomerism. Lesson 3 includes Fisher projection formulas and Natta formulas. We will do separate quiz on that. Okay, again this is based on lesson 1 and lesson 2 of optical isomerism. Hope you guys tried it yourself. Let's see whether what all kind of shortcuts we can do and also mistakes that commonly can happen. Going into question number 1. The R and S configuration of these compounds are. So they are asking you R and S. Now let's go one by one. So this is my chiral carbon. So this is my chiral carbon. We have to do the priorities, and least priority has to be in the back side. So I know that oxygen is my priority 1. Then what all do I have? So if I take this carbon, what all I have is a carbon attached to 3 hydrogens, a carbon attached to 3 fluorines, a carbon attached to how many carbons? This carbon is attached to, in the carbon include in the carbon level of carbon 3 carbons, because this is a double bond and 2 carbon and then OH. Again understand, you are not going to be writing it like this in the exam. So this is priority 1, priority 2, carbon attached to fluorine wins over carbon attached to carbon and carbon attached to hydrogen. So this is priority 2. The carbon attached to carbon is priority 3 and this is 4. So I have 1, priority 2 here, priority 3 here. So I have this, correct? So that is going to be R, my least priority is away from me. When I go here right away, I can see that this is my least priority, number 4. Correct? Number 4 on the least priority. So what I can do 2 flips. I'm going to flip my NH2 for hydrogen. So this is hydrogen, this is NH2. Now whatever configuration is, it has become inverted. So I'm going to do again NH2 versus COOH. So this is COOH now, this is NH2 now. I have done 2 flips and my least priority is away from me. So this is easier. Now looking at the atoms bonded to this carbon, ignoring, let's even put all of them. Hydrogen, nitrogen, this is carbon, this is carbon, carbon, carbon. This carbon is attached to 3 oxygens. Okay, this carbon is attached to sulfur, hydrogen, hydrogen. So priority is 1. Carbon, carbon same, attached to oxygen, doesn't matter, 3, sulfur wins, so 2, 3. Okay, so this is my priority 1, this is my priority 2, this is my priority 3. So again R, R, R right there. So let's confirm whether this is S. So I'm going to flip these two. Okay, so let's do differently. One flip pani opposite matala. So this is CH3, this is hydrogen. Okay, so this carbon is attached to CH2. So I have a carbon attached to hydrogen, CH3. In the side la pathina CH2, C double bond O H. In the side la patha CH2, CH2. Inge pata carbon, this carbon is attached to, so this carbon 3 bonds kuduthirukanga, oru hydrogen irukku artham, matta rendume double bonded carbon. Okay, so doing priorities, obviously 3 hydrogen irukanaala idhaan third priority varum. Needless to say, hydrogen is fourth priority. CH2, CH2, carbon attached to oxygen wins, so this is priority 1, priority 2. So here this is my priority 1, this is my priority 2, this is my priority 3, correct? So clockwise R, நம்ம ஒரே ஒரு flip பண்ணிருக்கோம், anti-clockwise yes. So again, ஒரு flip பண்ணிட்டு வரப்போற configuration opposite ஆவும் எழுதலாம் இல்ல ரெண்டு flip பண்ணலாம். However is easy for you. So option is alpha. Looking to question number 2, this is a high level question but understanding காக இதை நம்ம போட்டிருக்கோம். Okay, so now see, this is a chiral carbon, this is a chiral carbon, this is a geometrical isomerism center. But one thing you want to know, in the group ஒரே group. Okay, so there could be symmetry along this axis. So you want to be able to remember that symmetry இருக்கும் இந்த axisல. Okay, so the total number of stereoisomer possible for x is 6, which is actually true. நம்ம 3 இருக்கு அப்படின்னா 2 to the power 3 8 னு சொல்லுவோம். Correct? But understand, இது என்னவா இருக்கலாம்? இது சிஸ்ஸா இருக்கலாம்ல. அப்போ x வந்து இந்த group. Okay, alright. So இது r இருந்து இது s இருக்கிறதும், இது s இருந்து இது r இருக்கிறதும் internal compensation. Okay, meso compound மாதிரி வந்துரும் இது. Okay, so ரெண்டு கட் ஆகுதுல உங்களுக்கு. So 6. Do not worry, இந்த லெவல்ல நீட் வராது. This is for you to look at a tougher problem and understand. Okay, இது எல்லாராலையும் முடியாது. That's why I don't give it in the exam, I give it in the quiz. Okay, so this is correct. இங்க cis பத்தி கொடுத்திருக்காங்க. Let's so if the stereochemistry of the double bond in x is cis, so இதுதான் cis ன்னு சொல்றாங்க. The number of enantiomer possible is 2. Number of enantiomers possible is 2, which is correct. So now this is cis. So what all can you have? You can have R or enantiomer S. SR RS. இது ரெண்டுமே வந்து மீசோவா மாறிடும். So இதுதான் கரெக்ட் உங்களுக்கு. Okay, this is very high level question. Now stereochemistry of the double bond in X is trans. Trans ஆயிருந்தா எதுவுமே cancel ஆகாது. You will have the maximum number of enantiomers. Okay, you will have RR is an enantiomer with SS. SR is different than RS னு வரும். Again, இந்த question உங்களுக்கு ரொம்ப tough இருந்தா leave it. It's okay. Let's go to this one. This is actually an important pattern question on monochlorination of methyl butane. So one thing we have not seen is we have not seen monochlorination examples. Okay, we are going to see that actually in hydrocarbon lecture. But at this point, at least basic example பண்ணனும் நம்ம 2-methyl butane. So butane, 2-methyl. Now, right away, I'm going to do monochlorination. Monochlorination possibilities are, I can have Cl here. I can have Cl here. Let me draw this here. I can have Cl here. I can have Cl here. So 1, 2, 3, 4 distinct positional isomers you will get. Okay, the total number of chiral compounds என்னன்னு கேக்குறாங்க உங்களுக்கு. இதுல இதெல்லாம் chiral-ஆ இருக்கும் அப்படினு. Okay, now let's see. If I put it here, is this going to be chiral? Look at this carbon. ரெண்டு methyl இருக்கு. So this cannot be chiral. But this will be chiral because attached to isopropyl group, methyl group, chlorine and hydrogen. So this is chiral. So there is one chiral compound. When you put it here, is it chiral? This carbon has H2. இதுலயும் H2 இருக்கும். இதுல ரெண்டு methyl இருக்கு. So this is not chiral. When I put it here, is this going to be chiral? So this is CH2. Correct? CH2. இது CH2. இது CH3. இது hydrogen இருக்கு. Look at it. This group is different, this group is different, this group is different, this group is different. This is chiral. This is a second molecule. This is the most important molecule because chlorine போட்ட carbon chiral ஆகாது. Chlorine போட்ட பக்கத்து carbon chiral ஆகும். See, here this is not chiral. எதனால ரெண்டுமே methyl group இருக்கு. ஆனா ஒண்ணுத்துல நான் chlorine போட்டா it's chloromethyl and methyl. It becomes different, so this becomes chiral. When I go here, is any of them chiral? This one has 2 methyl group. இதுல CH3 இருக்க முடியாது. CH2. So no. So there is 2 of them that are going to be chiral compounds. It's an important pattern. Geometrical isomers can be diastereomers. Simple. Take a word for it. They can be enantiomers as well, but high level. And the type of enantiomer is high level. JEE advanced level. Which of the following optically active compounds racemizes in dilute KOH CH3OH solution? What it means is, I said a word in our lecture. Racemic mixture in தனித்தனியா R தனியா S தனியா நம்ம பிரிக்கிறோம்னா அது பேரு resolution. Okay? Optical resolution. Now R தனியா S தனியா இருக்கிறத RS மாத்துறோம்னா R plus S. Okay, let's put it this way. RS இருக்கிறத R and S தனியா பிரிக்கிறோம்னா resolution. R உம் S உம் தனியா இருக்கிறத RS மாத்துறோம்னா racemization. So R இருக்கிறது S ஆவும் மாறலாம், S இருக்கிறது R ஆவும் மாறலாம். R plus S இருக்கிறது 50-50 இருக்கணும்ன்ற அவசியம் இல்லை, but it will become 50-50. So here whenever they ask you racemization, normally what they mean is either pure compound R எடுத்தீங்கன்னா RS மாறும், pure compound S எடுத்தீங்கன்னா RS மாறும். Okay, that's what they are asking you. Now all you have to figure out is there a chiral compound? Okay, now let's see this. இது நீங்க this is chiral. Here when you see this is chiral. Here when you see this is chiral, this is chiral. Correct? Now how do I decide? All of them are irukku. The key here is the one that has alpha hydrogen to C double bond O will racemize. இதுதான் C double bond O. இதுதான alpha. It will racemize. Okay? Now, why does this happen? High level, not actually high level, class 12 chemistry. Class 12 chemistry, where do you see this base with the C double bond O? Aldol condensation. Aldol condensation can alpha hydrogen because alpha hydrogen is taken away. So, alpha hydrogen acidic and the alpha hydrogen, if it is taken away, what will happen? Now double bond O, இங்க extra electrons இருக்கும். So hydrogen போயிடுச்சு. திருப்பி அதே hydrogen வந்ததுன்னா போன சைடே வரணும்ன்ற அவசியம் இல்லை, ரெண்டு சைடும் வரலாம். So you become a racemic mixture. So option is delta. This we will see it again when we do aldol condensation. Okay. Now question like number 5 and also question like number 2 do not expect in test that I am giving you. Question like number 2 will not come in NEET also, but good for understanding. Question like number 5 will come in NEET, but it is high level for now because we are just beginning organic chemistry. How many optically active stereoisomers are possible for butane 2,3 diol? Butane 2,3 diol. Okay, so now either chiral, இதுவும் chiral. So how many are possible? Optically active isomers. Now this can be என்னென்ன configuration இருக்கலாம்? R இருக்கலாம், S இருக்கலாம், RS SR. Now these two are same compound because this has mirror plane meso. So how many stereoisomers are there? So listen to the question very carefully. How many stereoisomers are there? 3. How many optically active stereoisomers? 2. So this is one compound. So I have 1. 3 stereoisomers. How many of them are optically active? 1, not optically active, 2. So read the question very carefully. The option is beta. How many structural including stereoisomers possible for replacing one hydrogen of propene with chlorine? So we have seen this question actually before. Propene, ஒரே ஒரு ஹைட்ரஜன் மட்டும் எடுக்கிறோம் அப்படின்னா what can you have? Chlorine, double bond, C double bond, ClC, and then C double bond, Cl. Okay, so this is what we have right now. How many structural isomers possible? Now here if you see, this can give you So இங்கே ஒரு hydrogen இருக்கு. So this can give you cis and trans. Can this give you cis and trans? No, ஏன்னா CH2. இதுவும் cis and trans தர முடியாது. So I have two of them, 1. Two geometrical isomers of this compound, one structural isomer, another structural isomer. Total is 4. Okay, this one. How many stereoisomers are possible? Very simple. You just have to figure out chiral carbons. Is it chiral? No. So I'm going to put blue dots on things that are not chiral. Okay? Chiral edu illaya adha blue dot poda poren. This is not chiral. Now this is not chiral. Rendu CH3 group irukku. Rendu CH3 group irukku. Not chiral. Right away, easy. Okay? Now let's put red dots on ones that are chiral. Now this is attached to some group, a hydrogen and methyl. So this is chiral. This is attached to some group. I don't need to know what group. In the side வேற மாதிரி இருக்கு. So different hydrogen not shown and bromine. Yes. This one methyl, some group hydrogen. Yes. So 2 to the power 3 is 8. Alright, question number 9. Identify S4-chloro 1-methyl cyclohexene. So the first thing you have to do here is do not worry about S. Look at 4-chloro 1-methyl. So இது 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I don't give 1, 2, 3 this way. I don't give 1, 2, 3, 4 this way. Okay. We want to give 1, 2 to the double bond, and also chlorine and methyl are same. ரெண்டுமே ஏன்னா chlorine வந்து prefix தான் வரப்போகுது. So you don't give preference to chlorine here. So these two are wrong. Now between these two I need to figure out S isomer. That's all. Okay, hydrogen is away from me. So I have chlorine priority 1, hydrogen priority 4. In the side போகும்போது double bond இருக்கு, gets priority because that means extra carbon ல இங்க. So priority 2, priority 3. Anticlockwise. Hydrogen is away. So alpha. அப்ப இது என்ன இருக்கும்? Same except it is R isomer. So option is alpha. Only 2 isomeric monochloride derivatives are possible for monochloride derivative. So let's do one by one. Butane. Okay, 2 isomeric monochloride derivatives. Now can you put chlorine here? Yes, they are different. அப்போ ரெண்டு வரும். Okay, அதில் isomers இருக்கா இல்லையா அப்புறமா பார்க்கலாம். Now first let's figure out how many of them are there. Pentane 2,4 எங்கெல்லாம் போடலாம்? I can put chlorine here. I can put chlorine இங்கே ஒன்று தான். Okay, I can put chlorine here. This and this is same. This and this is same. So 3 different. So definitely no. Benzene monochloride derivative ஒன்னே ஒன்று தான் வரும். Okay, so no. 2-methyl butane. So இங்கே போடுறதும் ஒன்று தான். Okay, and then I can put it here. I can put it here. So too many isomers. So only 2 isomeric possible is alpha. Mesotartaric acid we already saw in the lecture is inactive due to the presence of. So now what do we have here? Internal compensation. So internal compensation is because of molecular symmetry. Asymmetry இருந்தா optically active இருக்கணும். External compensation is racemic mixture. 2 asymmetric carbon atoms. This is correct about mesotartaric but not the correct explanation. Alright, this will show. So here if you see, can this show different group? So it can show geometrical isomerism? Yes. Can it show optical isomerism? Yes. So option is Charlie. I'm going faster because you should have practiced the quiz by yourself once. The total number of chiral center in this compound is, so let's put dots here. Now இது ரெண்டுமே chiral கிடையாதுல, ethyl is never chiral. Okay. Is this chiral? Yes. இந்த சைடு வேற மாதிரி இருக்கு, இந்த சைடு வேற மாதிரி இருக்கு, hydrogen ஒன்று இருக்கு, ethyl ஒன்று இருக்கு. So this is chiral, this is also chiral. Okay, now is this chiral? No, இதுவும் chiral இல்லை. CH2 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 H2 இருக்கனால chiral இல்லை. Now I have to look into this position. When I look at this position, is it chiral? No, it's attached to a different group. But இந்த ரெண்டு சைடு ஒரே மாதிரி தான் இருக்கும் எவ்வளோ தூரமாக நீங்கள் போனாலும். So you have only 2 chiral centers. Among the following 4 structures, what is true? So they're asking about, just look at the options. Chiral edun kekranga. So when you look here, methyl ethyl propyl, this is chiral. When I go here, some group hydrogen methyl ethyl, chiral. இது chiral இருக்க முடியாது. இதுவும் chiral இருக்க முடியாது. இது ரெண்டும் சேம்ல chiral. 1 and 2 are chiral. So only 1 and 2 are chiral compounds. இது ரெண்டுமே எத்திலா இருக்கு, இங்க 3 ஹைட்ரஜன் இருக்கு. So it's impossible. Alright, consider the following. To make it chiral compound, attack should be on which carbon? Meaning basically என்ன கேக்குறாங்கன்னா, ஒரே ஒரு chlorine போட்டா என்ன ஆகும், இல்ல bromine போட்டா என்ன ஆகும் அப்படின்னு. Okay, we are getting familiar with the type of questions and what you are supposed to think. So இங்க chlorine போட்டா CH2 இருக்கும்ல அப்பயும், it is not going to be chiral. Okay, இதில் போட்டா chiral வராது. Now carbon 2 கொடுக்கல, but let's see. carbon 2ல நான் ஒரு chlorine போடுறேன், ஒரு ஹைட்ரஜன் எடுத்து chlorine போடுறேன். அப்போ என்ன குரூப் இருக்கும்? மெத்தில் 1 2 3 4 5, பென்டில் ஒரு ஹைட்ரஜன் ஒரு chlorine. ஸோ இங்கே அட்டாக் ஆனால் கைரலாக மாற வாய்ப்பு உண்டு. 3லேயும் அதே மாதிரி தான், எத்தில் அண்ட் சம் அதர் குரூப். 4ல போட்டோம் அப்படின்னா will it be chiral? Okay, I have 1 2 3 propyl group, 1 2 3 propyl group. So 4ல போட்டால் கைரலாக ஆகாது. எதனாலனா ஒரு ஹைட்ரஜன் ஒரு chlorine, இந்த சைடு இருக்குது propyl, இந்த சைடு இருக்குது 2 propyl groups are attached. So 4 will not be. Will 5 be chiral? Yes. 6 be chiral? Yes. ஏன்னா symmetrical moleculeனால இப்படி போனாலும் 1 2 3 4 5 6 7 போடலாம், இப்படி போனாலும் போடலாம். So I can have 2 3. There is no 5 6 and 7 carbons. நம்பரிங்கில் பார்த்தீங்கன்னா, okay, so option is 3. The molecules that exist as mesostructure, எது mesoவா இருக்குன்னு கேட்குறாங்க. Very simple. Correct? Plane of symmetry. There is no plane of symmetry. So both K and L is meso. An optically active compound is 1-bromobutane. It's better that you are able to visualize, but example risk எடுக்க வேண்டாம். We can draw it very small. 1-bromobutane, impossible. Beta-bromobutyric acid. Butyric acid, okay, alpha beta, beta bromo. Okay, so this is different, or hydrogen or bromine. So far this seems okay. Let's not make a mistake. We'll make sure. 2-bromo 2-methyl propane, 2-methyl 2-bromo, same, so impossible. 1-bromo 2-methyl propane, impossible. 2 methyl இருக்கு. So option is beta. A compound with molecular formula shows optical isomerism. The compound would be, alright, first thing you want to do, okay, see whether you have done the same way I am doing when you tried it yourself. Hopefully you have tried it yourself already. What is the first step you do? Think for a second. First step என்ன பண்ணுவீங்க நீங்க இதுல? The first step I will do is to make sure there is 7 carbons in the given compound. Okay, sometimes NEETல ஈஸியாக வரும், JEEல தான் கொஞ்சம் கஷ்டமாக வரும். டைமெத்தில், ஸோ 2 கார்பன் ப்ளஸ் 5 கார்பன் 7, டைமெத்தில் 1 plus 6. Okay, so the stem is okay. Now I'm going to look at what is possible. Compound shows optical isomerism. So pentane 1 2 3 4 5, 2,3 dimethyl pentane, 1 2 3 4 5, 2,2 dimethyl pentane, 1 2 3 4 5 6, 2-methyl hexane. So பார்த்தாலே தெரியும் இது வராது, ஏன்னா same, everything is same. Now when I go here, I cannot have chiral. CH3, H2, 3-methyl group, this one. What are the groups attached here? Hydrogen, இந்த கார்பனுக்கு hydrogen, methyl, methyl, some group. So this cannot be chiral. Let's go to this carbon. Okay, what is attached? Ethyl, ethyl, இந்த சைடு, இங்கே methyl இருக்கு, இங்கே hydrogen இருக்கு, இங்கே isopropyl இருக்கு. So this is going to be our option. Number 19. The number of stereoisomers possible for a compound of the molecular formula. Okay, they have given you the stem itself. Now I can have this position showing you stereoisomerism and also this position showing you stereoisomerism, correct? Carbon is attached to some group, I don't care what it is different than the three other groups, hydrogen, hydroxy and methyl. So I have two stereogenic centers. So the way to say it is stereogenic centers. So 2 squared is 4. The number of pairs of enantiomers and diastereomers for the given compound is. Okay, let's see first chiral carbon figure out panano. Either some R group. Okay, but it's alkyl group, so assuming that no carbon inside this is chiral, but this is chiral. And similarly, this is chiral. Okay, so that's all we have. So now NLR possibilities. Number of enantiomers, pairs of enantiomers and diastereomers. Either R S R mirror image. R S R S R. These two are two pairs of enantiomers. So wrong. 2 is correct, 2 is correct. Now how are these related? Diastereomer. Similarly, diastereomer. 4 pairs of diastereomers. Okay, so if you want me to write, the enantiomers are RR, SS is enantiomer, RS, SR is enantiomer. Diastereomers are RR, RS, SR is a diastereomer, SS, RS, SR is a diastereomer, so total 4. Okay. Minimum number of carbon atoms for an alkane should contain in order to exhibit optical activity. This is the way you want to do. Optical activity irukano appadina, I need A, B, C, D group. Okay, let's draw an alkane with this. What is the simplest substituent you can have? Hydrogen. Okay, here they are not telling you isotopic. Isotopic in that in your deuterium, tritium potalam. Isotopic illa. So what is the minimum number of carbon you can put? 1 carbon. What's the minimum? Second minimum you can put 2 carbon. What's the third minimum you can put? 3 carbon. Okay. In the 3 carbon, ippidiyum podalam. Ippidiyum podalam. Doesn't matter. Propyl or isopropyl is the same. So you need to have 1, 2, 3, 4, 5, 6, 7. 7 carbons. Now what we can do is, okay, I have done 7. Am I missing something? Minimum number kekrangala 6 carbon la panni paapom. Carbon, hydrogen, carbon. We'll start. Okay, minimum number 4 போட்டிருக்கோம். நம்மளால முடியாது ஏனா மெத்தில் இருக்கு. So ஒரே ஒரு மெத்தில் மட்டும் எத்திலா மாத்தலாம். முடியுமானா ரெண்டு மெத்தில் இருக்கு முடியாது. So 1 2 3 4 5 க்கு முடியாது. Okay, so let me put one more ethyl. முடியுமானா அப்பவே முடியாது. So I have to make it propyl. So option is 7. Which of the following compound will not have diastereomers? Okay, so now let's draw this compound. First one, right away it's easy to see anyways. OH, H, CH. Oh, okay, that's not the one given. They're giving you C, COOH, C, COOH. So, ரெண்டு COOH இருக்கு, ரெண்டு carbon account பண்ணிட்டேன், ரெண்டு hydrogen, these 2 hydrogens, and now I account for 2 OH groups. What they are giving you? They are basically giving you tartaric acid. Okay, so will not have diastereomer. So tartaric acid. So tartaric acid 2 chiral centers irukku. Let's go to this one. How many chiral centers are there? Only 1. Idhula evlo chiral center irukum? This one. Let's draw this. 1, 2, 3, 4, CHO, 5. 1 plus 4 plus 1, 6 carbons. Okay. இதில் எல்லாத்துலேயுமே OH 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 CH2OH, nothing but a diastereomer of glucose. We are going to see this later. Now இதில் வந்து இங்கே வந்து CH2OH மாதிரி இங்கேயும் போட்டிங்கனாலும் இங்கே diastereomer வரும். So these two will have diastereomer. Okay, but this will have diastereomer, but this will not have diastereomer. What is the diastereomer of this one? So tartaric acid என்ன இருக்கலாம்? We can have RR, correct? இது ரெண்டுமே RR இருக்கலாம், SSR இருக்கலாம், RSR இருக்கலாம். RS na internal composition, this is meso. So what are these two? These two are enantiomers. What are these two? Diastereomers, diastereomer. So tartaric acid, like we saw, has one pair of enantiomer and two pairs of diastereomers. But this cannot have. Diastereomer வேணும்னா உங்களுக்கு minimum 2 கார்பன் இருக்கணும். நோட்ஸ்லயும் அதை நான் சொன்னேன் உங்களுக்கு. You need minimum 2 chiral carbons. Okay, minimum. The reason is minimum R க்கு S மட்டும் தான் enantiomer. I cannot draw diastereomer. But if you have minimum 2 chiral carbon, I can have these possibilities. Enantiomer, enantiomer, diastereomer, 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 diastereomer. Okay. Now இதிலேயே வந்து இது ரெண்டுமே வந்து enantiomer எப்போ இருக்காதுன்னா meso, like tartaric acid. Which pair is diastereomer? Which pair is diastereomer னு கேட்குறாங்க உங்களுக்கு. First thing we want to do is we have to compare like versus like. Now look at it. 3 OH லைனாக இருக்குது, ஒரு O பக்கத்தில் இருக்குது. 3 OH லைனாக இருக்குது, ஒரு O. So maybe these two. 3 OH லைனாக இருக்குது, ஒரு கார்பன் விட்டு ஒரு O. 3 OH லைனாக இருக்குது, ஒரு கார்பன் விட்டு ஒரு maybe these two. So you cannot compare this and this and this and this. Understand? This and this are positional isomers. ரிங்கே வேறு மாதிரி இருக்குல்ல, positional isomers. Functional group ஒன்று தான். 1 and 2 are positional isomer, 1 and 4 are positional isomer, 3 and 2 are positional isomer, 3 and 4 are positional isomer. 1 and 2 are same, okay? They are related in terms of stereochemistry. So இங்க என்ன இருக்குன்னு பாருங்க, OH is in the front, OH is in the front, OH is in the back. Okay, but இங்க அதே ஆர்டர்ல இல்ல, front backல இருக்கு, front back frontல இருக்கு. When you look here, back front back, front back front, exact opposite இருக்கு, correct? So now actually what will happen is, if you rotate this molecule along this axis, you will actually get this one. நீங்க ஒரு molecule rotate பண்றீங்கன்னா உங்க முன்னாடி இருக்கிறது, imagine something facing you, you rotate it around 120 degrees. உங்களுக்கு பின்னாடி இருக்கிறது, if let's say imagine that you are looking at the board that I am teaching, போர்டுக்கு பின்னாடி இருக்கிறது 180 degrees சுத்தும் போது உங்க முன்னாடி வந்துடும். உங்க முன்னாடி இருக்கிறது போர்டுக்கு பின்னாடி போயிடும். I am not changing the molecule, I am just rotating the molecule. So they are same, but 1 and 3 are not same. இது frontல இருக்கு, திருப்புனா backல போகும். So இதோட same compound எப்படி இருக்கும்? Back, front, back. See again, I don't have to do R and S. If you want, you can do R and S. Okay. Let's even do, because we are revising it. Let's do. Let's take this carbon. Carbon priority வந்து இது 1, correct? இந்த carbon 2, ஏன்னா OH ஓட attach இருக்கு, இது வெறும் இதுதான். So according to this carbon, I have 1, 2, 3 hydrogens in the back. So this is R. இந்த carbon எடுத்தீங்கன்னா is attached to COH, COHO. So இதுதான் priority 1. Is this priority 2 or is this priority 2? This is priority 2 because for this carbon, இந்த carbon ஒன்று தான். So you move to the next atom. Oxygen gets wins. So for this one, this is 1, this is 2, this is 3. R. When I go here, obviously, இது O, இதுவும் O. Which gets priority? This O, because it's attached to carbon, it's attached to hydrogen. So இது 1, இது 2, இது 3. So I have S. R, R, S. Okay. Now what we have to be careful is, இது வந்து R ஆ இருக்காது, S ஆ மாற்றணும். எதனாலனா OH பின்னாடி இருக்கு, I just flip it. Okay, so I have here R, S, S. Okay, when I go here, this carbon, my priority is 1, 2, 3, correct? oxygen, oxygen, carbon. So I have R. When I go to this carbon, I have carbon attached to oxygen, carbon attached to oxygen. This is attached to 2 oxygens. Correct? This is attached to 2 oxygens, that carbon, whereas this carbon is attached to only 1 oxygen. So, in the carbon எடுத்துக்கும் போது இதுதான் priority 1. OH priority 1, இந்த carbon priority 2, இந்த carbon priority 3. 1, 2, 3. So, this is S. And then I have here priority 1, priority 2, priority 3. So, it's going to go this way. It's S, but it becomes R. Okay, correct? ஏன்னா ஆக்சிஜன் பின்னாடி இருக்கு. Now, இதே ஆர்டர்ல எழுதலாம் நம்ம. Let me use a different colored pen. Actually, what I'm going to do here is இந்த ஆக்சிஜன்ல இருந்து பார்க்கலாமே. இப்படி போகும்போது இது என்ன இருந்தது? S இருந்தது. இது நம்ம S ன்னு சொல்லிட்டோம். இது நம்ம R ன்னு சொன்னோம். ஸோ ஆக்சிஜன்ல இருந்து போகும்போது எனக்கு S, S, R. ஆக்சிஜன்ல இருந்து போகும்போது R, S, R. These two are diastereomers. Let's go to this carbon. What's the priority? This is priority 1, priority 2 இங்க இருக்கும், priority 3 இங்க இருக்கும். Correct? This is priority 2 because attached to O. This is priority. So this carbon is attached to O. Oh, wait a minute. This carbon is attached to OH. This carbon is attached to OC. So this is priority 2. Correct? This is priority 3. So I have 1, 2, 3 S, but becomes R because OH is away. Okay? So this is R. Let's remember that. This is R. In the carbon edutha, oxygen is 1. Okay? Oxygen is 1. We are okay. Now carbon attached to OH, carbon attached to OH. CH2, CH2O. ரெண்டு ஒரே மாதிரி இருக்கு. So this is actually, sorry, I shouldn't put that symbol. இது R. This is not going to be chiral because it is a plane of symmetry. Similarly, this also is a plane of symmetry. Okay? So, இது என்னவா இருக்கும்? Plane of symmetry னா automatically இது S இருக்கும். Okay? Now, இது என்னவா இருக்கும்னா இது S, இது R இருக்கும். R, S, SR are same compound if it is a plane of symmetry is there. So, these two are meso compound. Okay, so what I would do if I were you is practice it again. Maybe draw this molecule big in your notebook and explain yourself and attach. In the Mari example will teach you multiple concepts at the same time. Okay, so 1 and 3 are diastereomers. So 1 and 3, delta is the option. 24, the pair that represents a pair of enantiomer. So we are going to do the same but fast now. Mirror plane, mirror plane. Okay, so meso, the rendu one compound. So 3 and 4. See how simple it has become right now. An organic molecule necessarily shows optical activity if optical activity irukano appadina necessarily contains asymmetric carbons. Yes, is non-polar, is non-superimposable on its mirror image. Okay, is superimposable on its mirror image, same compound. It shows necessarily optical activity if contains asymmetric carbon. So, if you decide panna, then this is not right. It can contain asymmetric carbon, but it can be superimposable. Meso compound irukala. So, this is the option. Charlie. 26. How many stereoisomers are possible for the compound? Okay. So, now right away we know that this rotation is forbidden. முடியாது உங்களால ஏன்னா free rotation முடியாது biphenyl. So that is going to give you one stereogenic center. And do you have any more stereogenic center? Yes, here cis trans. So one stereogenic center plus one more stereogenic center plus this is a chiral carbon. One more stereogenic center. 2 to the power 3 is 8. It's not a tough question, a tricky question. Again, I'm training you guys to look what to look for in a problem when it is given. First, stereoisomers total keta. First, enna paakano? Number of stereogenic centers. So I go carefully and mark it. 27. The two compounds given below are. Okay, so now take this molecule. இது பின்னாடி இருக்கு, இது முன்னாடி இருக்கு, இங்க இது பின்னாடி இருக்கு, இது முன்னாடி இருக்கு. Okay, what we are going to do right now is we are going to rotate it 180 degrees. Okay, rotate it 180 degrees போது இது பின்னாடி இருக்கிறது இதை நான் வந்து இந்த ஆக்சிஸ்ல ரொட்டேட் பண்றேன் along this axis. Okay, so இந்த ஆக்சிஸ்ல ரொட்டேட் பண்றேன். I'm going to rotate it 180 degrees. அப்ப முன்னாடி இருக்கிற OH வந்து பின்னாடி போயிடும்ல. It's facing you 180 degrees rotate பண்ணும்போது போர்டுக்கு பின்னாடி போயிடும். போர்டுக்கு பின்னாடி இந்த COH முன்னாடி வந்துடும். So it's the same compound. Okay, that's one way of thinking. Second way of thinking is this cannot be drawn this way. There is no front and back. It's on the plane of the board. You have sp2 carbon. What is the shape? Trigonal planar. நம்ம இதை வந்து chemical bonding ல பார்ப்போம். But at this point I want you guys to get used to these tricks that they can give you. இது front and back இருக்கவே முடியாது. இது plane of the paper ல தான் இருக்கும் actually. Alright, how many stereoisomers are possible? So very simple, stereogenic centers கண்டுபிடிக்கணும். See, this is not going to be hydrogen இருக்கு. This is also not going to be because இந்த கார்பன் கூட ரெண்டு மெத்தில் இருக்கு. So no. This carbon has CH கொடுத்திருக்காங்க. So you got to be very careful. So let's draw this. This carbon is that attached to hydrogen, methyl. Okay, let's put the numbering as not IUPAC numbering, just numbering here to not miss a carbon. So 6 carbons, 1, 2, 3, 4, 5, 6. Second carbon la hydrogen irukku. Third carbon la hydrogen கொடுத்திருக்காங்க. Fourth carbon la ரெண்டு hydrogen. Fifth carbon la hydrogen OH. Sixth carbon la hydrogen bromine hydrogen. So now right away what you need to know is what is missing. Hydrogens are missing here, meaning that's a double bond. Hydrogen கொடுக்கலனா கூட பரவாயில்லை, கம்மியா கொடுத்திருக்காங்கன்னா it's a double bond. So now what are all the possible places? So this is a possible stereogenic center. Is this chiral? No. Is this chiral? Yes. Is this chiral? No. So 2 squared, 4. Which of the following compound is not chiral? Okay, so let's see whether it is not chiral. CH2. This is not chiral. Let's look here. In the carbon la hydrogen, deuterium, some group. It is chiral. So this carbon is chiral. This is the same hydrogen, methyl, chlorine, and different group. So this is chiral. This carbon is chiral. Hydrogen, deuterium, chlorine, and some group. So these three are chiral. This is achiral. So that's what they're asking you. Alright, last one. Which of the following compounds are identical? Just like before. Okay, now I think you guys can do it. The first thing we want to do is compare these two and compare these two. Correct? Position of oxygen lay solidum. When I want to compare these two, best thing is identical இருக்கும்னா usually meso இருக்கும். Now, is this meso? This is not meso, okay? Because mirror plane illa. But one thing I can say is front, back, front. It's not going to be same compound as front, back. So these two are diastereomers. Now there is a mirror plane. So these two are identical compounds. So 2 and 4 are identical. See how fast it becomes. Now a word of note. In the example, இப்போ நான் சொல்லும்போது உங்களுக்கு புரியும். When we do revision time, you will forget that how you got this fast. So write down notes along with us saying that look for mirror plane. If there is a mirror plane, in both compounds and the arrangement of atoms skeleton is same, then they are meso compounds. So they could be same, okay, and they are chiral but optically inactive. They are not diastereomers. Alright, okay, hopefully you guys are able to follow me through this. Now do the paper again and also do the Monday test. You're going to be okay with optical activity. Optical activity is something where it takes a lot of time to understand now, and then later என்ன இருக்கும்னா ஃபுல்லா ஆரம்பத்துல இந்த R&S உடனே பார்க்க வந்துரும். Just right away either diastereomer enantiomer பார்க்கறது மறந்து போய்டும். நோட்ஸ் கிளியரா எழுதிக்கிட்டீங்கன்னா அதுவும் ஈஸியா இருக்கும். Also we will be doing revision later as well. Okay, good luck guys.